Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 3 in the authentication module titled Password Reset Broken Logic. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy, select all labs, and then do a search on Authentication Labs and go to lab number 3 titled Password Reset Broken Logic. Alright, let's get started. This lab's password reset functionality is vulnerable. To solve the lab, reset Carlos's password, then log in and access his My Account page, and then you're given your credentials and the victim's credentials. Alright, so the idea over here is you know the victim's username and you want to be able to access his account, however you don't have his password. And the way we're going to do that is we're going to exploit a vulnerable password reset functionality in order to reset Carlos's password and then log into Carlos's account. Okay, let's access the lab. Now notice over here, this is the built-in browser in Burp, and so all my requests are already being passed in my Burp proxy. Now, the first thing that we're going to do is test the reset functionality for our user account that we have. So we're going to put in his username, hit submit. Now it makes a post request to the forgot password functionality. And if we look over here, it just takes in the username and it sends the password reset link to the email address. So let's click on email client and click on the forgot password reset link and look at that link over here. So it was this link right here. Let's send that to repeater. It has the temporary forgot password token and that's it. It's a GET request, and then let's reset the password to, let's say, password and confirm it, hit submit and see the request that is performed by the application. So it's a post request. Let's send that to repeater again. It takes in the temporary forgot password token in the URL, but it also has a bunch of parameters it takes in over here. So one of them is the temporary forgot password token, the username, the new password, and then the confirmation of the new password. Now, it takes this in twice, so I'm wondering if it just compares these two tokens together and it doesn't actually have to be a valid token. So let's just keep this at X, but make sure that it's equal to the one over here. So X, and then just change the username to Carlos and see if that works. Hit send. We get a 302, so that is a good sign. Hit forward and it just leads us to the main page of the application. So let's click on My Account and see if that works. So Carlos, and then let's just say the password is password, which is what we reset it to. Hit login. And here we go. It says, congratulations, you solved the lab because we were able to access Carlos's account. So the vulnerability over here is in the implementation of the forgot password functionality. It looks like it compares this parameter to this parameter, and if it's equal, then it allows you to reset any user's account. It doesn't actually check to see if this is a valid temporary forgot password token and that that token is linked to the user that is requesting the password reset. And that's why we were able to exploit it. All right, so we successfully exploited the vulnerability manually. Now let's script it in Python. As usual, the first thing that we're going to do is import all the libraries that we want. So the request library, the sys library, and the URL lib3 library. And let's remove that so that it's bigger. Next, we're going to disable insecure request warnings. So disable warnings, URL lib3.exceptions. Insecure request warning, and then we're going to set our proxy setting so that all the requests get sent to Burp in case I need to debug them. So all of HTTP traffic should be sent to HTTP 127.0.0.1 port 8080. Same goes for all the HTTPS traffic. It should be sent to HTTP 127.0.0.1, and again port 8080. And then we define our main method. So if name is equal to main, and that should be in quotes, then call the main method, and we'll define it right over here. So def main. If the length of the command line arguments, this is .argv, is not equal to 2, then print the example instructions and the usage instructions. So usage is the name of the program, and then URL and the name of the program we take from the command line argument. Same goes for the example instructions. So www.example.com, and the name of the program is taken from the command line argument, and then we exit the program because the user ran it incorrectly. All right, let's assume the user did run it correctly. We'll create a sessions object. So request.session, and then we'll create a URL variable, and we'll take that from the command line argument. And then we'll call a function called access Carlos account, and that takes in the session object and the URL. And that's a custom function that we'll define right over here. So def access Carlos account takes in the session object and the URL. The first thing that we're going to do is reset Carlos's password. So we need the URL to the reset functionality, but first we'll print resetting Carlos's password, and we'll define the URL right over here. So password reset URL is equal to URL plus the URL to reset the password, which is this one right over here. Let's copy that and put it in here. Next, we need the password reset data, which is equal to this entire thing right over here. And this is a really dangerous vulnerability because it allows you to reset all the users and the passwords of all the users in the application. However, it doesn't go unnoticed because when the user wants to log into his account, he'll realize that his password was changed. And if you do it for a ton of users, you're going to get caught really quickly. So username, Carlos. And we've got the new password. Password and new password 2. And again, password. All right, hopefully I didn't make any mistakes. Next, we just perform the request. So r is equal to s.post. It takes in the password reset URL. Data is equal to password reset data. Verify is equal to false because I don't want to verify TLS certificates. And proxies is equal to proxies. And then the next thing to do is access Carlos's account after you reset his password. So to do that, we're going to print logging in to Carlos's account. And for that, we also need the login URL, which is just equal to the URL of the main application plus the path login. And then we need the login data. And for that, we need to go to proxy, and it's a post request, and the login data is just the username and password. So username is Carlos, and password is the password that we reset. So that's also just equal to password. And then we just confirm that the exploit worked. So confirm exploit worked. And the way we're going to do that is we're just going to check if logout is in the response, so r.text. If it is, then we successfully logged in as the Carlos account. So successfully logged into Carlos's account. Otherwise, we'll print exploit failed. And we'll end the program. All right, let's save this. Hopefully I have no errors, but before I run the program, this is probably timed out, so let's just open a new instance of the lab. Right click, open link in new tab, and while that loads up, let's get our terminal ready. So terminal, new terminal, Python 3, authentication lab 03.py, copy this, paste it in here and remove the trailing slash, hit enter. And it says my exploit failed. So let's go to burp and find out why. So this looks like it passed, and I know why. Okay, so over here, it only made a request to the slash endpoint. It didn't make a request to the slash login endpoint. And that's because we never made the request over here. So r is equal to s.post. And that's why you always pass all your requests in burp, just so that you could know how to debug your script if it doesn't work. So you need to make the request. So login data, and then you've got data is equal to login data. Verify is equal to false, and proxies is equal to proxies. So it needs to actually log in before it looks for the logout string. So let's clear this and run it one more time, and hopefully it'll work this time around. And we get an error. And that's on line number 21. Okay, and it's this over here. So it's login URL, not login data. Let's save it, clear it. This is what happens when you're doing something really quickly. Hit enter. Hopefully there's no more errors. And here we go. It says congratulations, you solved the exercise, and you could see it over here. All right, so we successfully completed the exercise by exploiting the vulnerability manually and then scripting it in Python. In the next lab, we'll look at another case of a broken authentication vulnerability.